What would happen if an uninvited cosmic visitor took a return trip from interstellar space? Well, back on October 19, 2017, the universe presented us with a truly extraordinary discovery. Robert Weryk, an astronomer at the University of Hawaii at Mānoa, using the Panoramic Survey Telescope and Rapid Response System in Hawaii, stumbled upon a captivating object. From the beginning, it was evident that this object defied all conventions. Its orbit, speed and properties were simply strange. It appeared as if out of nowhere, making a fleeting appearance before receding into the cosmic abyss. Now, thanks to the extraordinary capabilities of the James Webb Space Telescope, we have seen this mysterious visitor again, and it is making a return. What is even more disconcerting is the recent revelation about his reappearance. But what do we really know about this cosmic traveler, Oumuamua? What does his return mean? Stay until the end, because we could be heading into something incredibly disconcerting. On that fateful night of October 19, 2017, astronomers at the Pan-STARRS telescope on Maui embarked on an ordinary mission to observe the celestial canvas above them. However, they soon discovered a cosmic revelation of unprecedented magnitude. From the vast expanse of the night sky, emerged an object of unparalleled peculiarity, a celestial entity unlike any seen before. This object, with an astonishing speed of 87 kilometers per second and a deeply elliptical trajectory, declared its interstellar origins while venturing into the heart of our solar system. It marked an extraordinary milestone as the first interstellar object detected. What made this cosmic visitor even more enigmatic was its shape, which strikingly resembled a cigar. Despite its extraterrestrial origin, it had relatively tiny proportions, being just 1,150 meters long and 19 meters wide. However, the most disconcerting revelation was yet to come. Oumuamua, later baptized with his Hawaiian name meaning messenger from afar who arrives first, continued his journey through the cosmos, manifesting a disconcerting acceleration that defied the gravitational influence of our Sun. This puzzling phenomenon led the most rational scientists to consider the possibility that this object could be an alien spacecraft equipped with its own propulsion system that propelled it through our solar kingdom. Adding to the intrigue was Oumuamua's unconventional trajectory. Unlike the predictable elliptical orbits seen in asteroids and comets, Oumuamua charted a bold hyperbolic path, leaving no room for ambiguity about its extraterrestrial origins. The deeper astronomers investigated its nature, the more it eluded their understanding. The reddish hue of it, indicative of cosmic bombardment throughout cosmic epochs, added another layer to the mystery of it. However, there was one conspicuous absence on this celestial wanderer: the lack of the familiar tail, or halo typically associated with comets, as they gracefully interact with the warm glow of the sun. This was not simply an astronomical anomaly. It was a profound enigma that left the sharpest experts in the field struggling with perplexity. The mystery deepened as scientists grappled with the question of why Oumuamua, contrary to all expectations, was accelerating instead of slowing down, as it should have done according to conventional celestial mechanics. Several hypotheses emerged with fervor, some suggesting it could be due to gas emissions. A common phenomenon in comets is that they release gases that propel them, but evidence of this process was lacking in Oumuamua. This led to bold guesses. Could it not be a natural product but a space probe designed by aliens to explore our galaxy? Professor A.V. Loeb of Harvard proposed this idea, which, although met with skepticism, generated interest. The James Webb Space Telescope, an engineering marvel, has rediscovered Oumuamua, opening new perspectives on our knowledge of the cosmos. This telescope makes us active participants in an exciting cosmic exploration that could change our understanding of existence. The telescope has used its advanced infrared vision to reveal details of Oumuamua that were previously invisible to us. Its trajectory is surprising. Unlike its first fleeting visit, it now moves defiantly through our solar system, without being influenced by the gravity of other celestial objects such as comets or asteroids. It's close to Mars, which adds more intrigue. Why has he returned, and what does his different path mean? These are important questions for scientists around the world. The return of Oumuamua is not only a cosmic event, but a call to explore the mysteries of the universe. We might find answers within this moving celestial enigma. Additionally, Oumuamua displays unusual behavior, emitting bursts of energy that are different from what we know from natural space objects. It also appears to have undergone changes to its surface, suggesting external influences or mysterious processes that we do not yet understand. The big question is whether Oumuamua has a message to convey. Is it just a unique space rock, or does it hide something deeper in its history? As he travels through our solar system, he challenges scientists to unlock its secrets. When we discovered Oumuamua, many theories emerged to understand it. One of the main ones suggested that solar radiation could have propelled it, like wind drives sailboats on Earth, although this is not common in space. There was also talk of the possibility that Oumuamua emitted gases, as comets do, to move. Some even thought it could be a nitrogen iceberg calved from a Pluto-like planet in the past, but this seemed unlikely due to the lack of pure nitrogen on Pluto and the universe in general. Natural explanations for Oumuamua raised new questions. Why didn't it behave like a normal comet, and why did it have a unique elongated shape? Some have even speculated that it could be more than just a space rock, perhaps a probe from a distant civilization. Its strange acceleration suggests the possibility of intelligent control or a propulsion system. However, we still do not have solid evidence to confirm this. The return of Oumuamua gives us the opportunity to learn more and unravel its mysteries. It also makes us think that it is not the only object like this in the cosmos. The universe, with its many galaxies and objects, could be full of Oumuamuas traveling through interstellar space and telling us stories from other places. What do you think of this exciting idea? Now, a new comet is on its way to Earth and promises to shine as bright as Polaris itself, the North Star. The discoverer of this celestial visitor is the enthusiastic Japanese astronomer Hideo Nishimura, who sighted it on the night of August 11, 2023. This achievement marks the third comet that Nishimura has had the honor of discovering. The most extraordinary thing is that he identified the comet while it was still beyond Earth's orbit, before any automated space observation instrument, such as Pan-STARRS, CTF or Atlas. At that time, the comet had an apparent magnitude of 10.4, that is, about 40 times dimmer than a star that can barely be seen with the naked eye. As the comet approaches the Earth and the Sun, its brightness increases. Until August 26, its magnitude shot up to 7.9, experiencing a tenfold increase in intensity compared to the night of its discovery. The official name of the comet is C/2023 P1 Nishimura. Now, what is the logic behind this name? Well, the name of a comet says a lot about its nature, origin, and discovery. The naming system for comets and asteroids follows a well-defined pattern. It begins with a prefix that indicates the type of object. In this case, C/ denotes a non-periodic comet that takes more than 200 years to orbit the Sun and may have an irregular orbit. The prefix is followed by the year of discovery, in this case, 2023, and a combination of letters and numbers representing the time of discovery. Each month is divided into two halves, labeled alphabetically, A for the first half of January, B for the second half, C for the first half of February, and so on. The accompanying number means the order of discovery within that period. Finally, you can add the name of the person, observatory, or telescope that discovered the object. So, C/2023 P1 Nishimura is a non-periodic comet, the first object discovered in the first half of August 2023 by amateur astronomer Hideo Nishimura. Comet P1 Nishimura will make its closest approach to Earth on September 12, 2023, followed by its perihelion, or closest approach to the Sun, 5 days later. It's a little disappointing that the comet didn't pass in December. If it had, it would have been an astonishing sight, coming within just 0.06 astronomical units, or about 9 million kilometers from Earth. The comet appears to have a strange orbit. It surprised us by coming from the south and from a direction close to the Sun, which probably explains why it was not detected earlier this summer. P1 Nishimura follows a retrograde path that is tilted about 129 degrees compared to the flat plane of the planet's orbits, or the ecliptic. This means that it moves in the opposite direction to the inner planets of the solar system. The comet also appears to have an orbital eccentricity slightly greater than 1, indicating that it is probably a new visitor to the inner solar system from the distant Oort cloud. After reaching its closest point to the Sun, it will likely be launched into galactic space in the direction of the southern constellation of Pyxis. According to Joe Rao, an instructor and guest lecturer at New York's Hayden Planetarium and Space.com skywatching columnist, if you're interested in seeing this new comet for yourself, be prepared to get up early, usually around an hour and a half. 2 hours before dawn. You'll need binoculars or a telescope to get a good view, as the comet is not yet bright enough to be seen with just the naked eye. It's also a good idea to be in an area with little light pollution, away from bright light sources. Having one of the space apps mentioned in the description will be helpful in knowing exactly where to direct your gaze. But the most vital tip is to find a place with a clear and open view of the sky in an east-northeast direction. This is the area where you will be able to see the comet. Starting August 26th and ending September 4th, the comet's path will take it through the faint stars of the crab-shaped constellation Cancer. Then, starting on September 5th, the comet will move across the top of the recognizable star pattern called the Weryk. This pattern forms an inverted question mark and represents the head and mane of Leo, the lion. Comet Nishimura will continue to brighten as we move through this period. By this time, around September 5th, it could become as bright as 5th magnitude, and there is a chance it could even be visible to the naked eye. 4 days later, its brightness could have more than doubled, possibly reaching 4th magnitude. As the comet approaches the Sun, it will appear increasingly lower in the east-northeast sky in the mornings. On September 9th it will be about 10 degrees above the horizon, about the width of a fist at arm's length. On September 12th, although it could become brighter and reach 3rd magnitude, it will still be just above the horizon. This will probably be your last chance to see it. You could also see the comet on September 17th, when it will be closest to the Sun. Some sources suggest that it could be seen in the evening sky, close to the Sun during sunset. At this point, P1 Nishimura could shine as brightly as a 2nd magnitude star. However, it will be only 11 degrees from the Sun, and the Sun's light will likely make it difficult to see the comet. The first week of September is the best opportunity to see a comet. We don't know much about its long-term path, but if its orbit is very elliptical, it will move away from the solar system after passing close to the Sun, and we won't see it again. Although Comet P1 Nishimura will not be as famous as others, such as Neowise, we have another comet on the way that could be very bright. It is called C/2023 A3 Atlas. It was discovered in 2023 when it was far from Earth, but is rapidly approaching. If all goes well, we'll be able to see it through small telescopes in 2024. By the end of September of that year, it might even be visible with the naked eye or binoculars before dawn in the east. It will be in the sky before the Sun rises. We don't know if it will have a tail at that time. That will depend on its age and activity. In October 2024, Comet A3 will pass very close to the Sun from our perspective on Earth and, as a result, will disappear from our view. If the comet manages to survive its approach to the Sun, it will reappear in the northern hemisphere sky around October 11th or 12th, 2024. At that time, it will be visible after sunset and will gradually rise in the sky each night, making it easier to spot. Observation. If all goes according to plan, Comet A3 will become brighter than most of the stars we see at night. However, comets are unpredictable, and we cannot be sure what exactly will happen. So we just have to wait patiently for this special visitor from space to come closer and see how it behaves. But since we realize that Earth might not be the only place where life thrives, we have been tirelessly chasing evidence of extraterrestrial life. The consequence of this urgency has been the creation of advanced equipment such as the Perseverance rover on Mars, the Hubble Space Telescope, and of course, the jewel in the crown, the James Webb Space Telescope. Since its launch, the James Webb has embarked on a constant mission to explore outer space in all directions and search for any evidence that suggests the existence of life beyond our planet. From tracking biosignatures to viewing the most distant galaxy cluster ever seen, James Webb is constantly discovering the new. In its early days, the Webb telescope has recently revealed that rocky alien worlds likely harbor abundant amounts of water even before their formation. Now let me explain why this is of great relevance, and what implications it has for the continued search for extraterrestrial life. As we all know, water is an essential source for supporting life on Earth. Scientists apply similar logic to searching for life in the universe. This has triggered the search for exoplanets that are in the habitable zone and contain a certain amount of water. However, many scientists continue to debate how water could have reached the Earth's surface. According to previous research, it is believed that Earth received much of its water from water-bearing asteroids that bombarded our planet's surface during its formation. Now, scientists have discovered evidence suggesting that water must have been one of the components available at the time of birth, which came together to form a rocky planet. Recently, researchers have focused on a young star, PDS 70, which is nearly 370 light-years from Earth and is about 5.4 million years old, compared to about 4.6 billion years old for our own star, the Sol. Using James Webb's infrared instrument, scientists have discovered water in the form of hot vapor at about 625 degrees Fahrenheit near the center of the disk of gas and dust surrounding the star PDS 70. The lead author of the study, an astrophysicist, Julia Perrotte, mentioned that this discovery demonstrates that water is present in the inner disk of this iconic system, where Earth-like planets could be forming. This finding is significant since, in our solar system, this central area is where several rocky planets formed, including Earth. By observing it, we can trace how the planets in our solar system formed and what their chemical composition was before their complete formation. The new findings suggest that any rocky planet that forms in the central zone of PDS 70 would contain a substantial amount of water and could eventually become habitable. As for how the water got to PDS 70, the researchers raised two possibilities. One explanation suggests that the water present in PDS 70 could have come from a water-rich nebula that formed the star. Another possibility is that the outer edges of PDS 70 could have been penetrated by oxygen and hydrogen gas, which then combined to form water vapor. If you think that this is an isolated case where James Webb has hinted at the possibility of extraterrestrial life, you are completely wrong. Let me take you through one of the most fascinating recent incidents. Astronomers using the James Webb Space Telescope have discovered evidence of complex organic molecules similar to smoke or soot in a distant galaxy. This is the oldest known sample of complex organic molecules in the universe found by humans. What it has achieved is that it has advanced the previous record for detections like this by about 1 billion years. I don't know about you, but it's both fascinating and terrifying to me that these discoveries at the edges of the universe are changing the foundations of our cosmology. This is a powerful discovery, and here's what changes. First things first, these chemicals have been detected within an early galaxy that formed when the universe was about 10% of its current age. Carbon-based molecules, technically known as polycyclic aromatic hydrocarbons, are found in oil and coal deposits on Earth, as well as in smoke. But what is the importance of this finding? Justin Spiker, the lead astronomer on the study, makes clear that the molecules we found are not simple things like water or carbon dioxide. We're talking about large, flexible molecules with dozens or hundreds of atoms in them. Isn't it amazing that the universe can create really large, complex molecules very quickly after the Big Bang, when our models suggest they couldn't have done so? Given the galaxy's great distance, the light astronomers detected began its journey less than 1.5 billion years after the Big Bang. The universe is currently about 13.8 billion years old. We are looking at the beginning of the formation of the universe as we see it today. But here's the key. It's thanks to the James Webb Telescope that we've been able to detect these complex organic molecules, surpassing the previous record for detections like this by about 1 billion additional years. Imagine if we could look even further back in time. Is it possible that we would find more of these molecules and also very close to the Big Bang? Where does that leave our science, our cosmological model? What's especially intriguing is the contrast between previous efforts to identify complex organic molecules in ancient galaxies and the new level of detail that the James Webb Space Telescope is providing. Previously, scientists could determine in a general way whether these substances were present or not in these distant galaxies. However, with the resolving power of the James Webb, we are witnessing a remarkable advance, as we are now able to delve into the intricate details of the exact location of these molecules within a galaxy. Turning our attention to an early galaxy designated DSFG 850.95, an additional mystery arises. We cannot ignore that the distribution of these complex organic molecules in this galaxy is not homogeneous, but rather presents peculiar patterns. The reasons behind this variability still require further explanation and analysis by scientists. This complexity adds a new level of questions about the chemical and physical processes that influence the formation and distribution of these molecules in the early stages of the universe. This discovery not only opens new perspectives on galaxy formation in the early stages of the cosmos, but also raises exciting questions about the abundance of materials essential for life in these remote environments. What was once considered a period of relatively little activity in terms of galactic formation is now presented as a crucial moment where galaxies were already taking shape and content. It is even more surprising that this early galaxy, despite its youth in cosmological terms, already exhibits comparable magnitude and richness in elements such as carbon and oxygen compared to our own much older Milky Way. The relationship between its mass and the formation of chemical elements is an intriguing testament to the evolutionary processes and fundamental forces at work in the early universe. As humanity continues its exploration of the unknown, supported by increasing knowledge and an unwavering desire to understand the cosmos, we find ourselves inevitably humbled by the immensity and complexity of the universe. With each step forward, our understanding sharpens and we get a little closer to unraveling the secrets that are carefully hidden among the stars. The wonder of how the James Webb Space Telescope is playing its part leads us to firmly believe that the universe is about to reveal itself in a new light, in a perpetual dance of discovery and wonder. Now, I would love to hear your thoughts and opinions on this fascinating scientific advance.